Okay, let's talk about semi-variable, or what we call mixed costs. So a lot of our costs have both a fixed and variable component. A good example that's shown here is a utility bill. So regardless of whether or not you use any electricity, you're still going to pay a minimum monthly charge to be hooked up and to have access to utilities. And then in addition, you also pay on a variable component. So your usage will be charged accordingly. You'll pay more if you use more. If you use less, you'll pay less. So the dilemma becomes, how do we separate those into both fixed and fixed and variable cost. Now remember, a variable cost is going to be dependent on the level of activity or the amount of usage. So a total cost there is going to be our fixed plus our variable cost. So let me give you an example. Actually, let me step back one time just to discuss the equation here. I skipped over that. So we can actually express that cost as an equation. So where y is our mixed cost, or our semi-variable cost, which equals a, the total fixed cost, plus b, which is the variable cost per unit, times x, which is the level of activity. Now if we jump back over here, we have an example here where we have a high level of activity, what the total cost was and for how many units, and a low level of activity, total cost, number of units. And we can use something called the high-low method to help us separate our variable cost from our fixed cost. So the first thing we need to do is calculate the variable cost per unit. And the way that we're going to go ahead and do that is take our change in cost over our change in units. So you can see the difference between the high and low levels of activity is $3,600, and that's a $4,000 difference in units. So we'll take the $36,000 divided by the 4,000 units. That's a 90-cent per unit cost. Then we're going to take that 90-cent per unit cost, and we're going to go ahead and try and separate the total cost from the total variable cost. Okay, so we know it's 90 cents per unit, and you pick either the high or low level, it doesn't matter which one you pick, and multiply that times the activity level at that particular one. So the high level of activity, that was for 9,000 units. So the total cost was $9,700, and we subtract the variable cost per unit of 90 cents times the 9,000 units at that level, activity level. That's going to give us a fixed cost of $1,600. So they're paying $1,600 and then 90 cents per unit after that. And then the last step here is going to be to actually convert that into the equation. So the actual equation may be a little hard for you to see. Let's see if I can change the font there. Is y equals 1,600 plus 90 cent x. So that's the fixed cost of 1,600 plus the 90 cent variable cost times y, which is our activity level. Let's see, we can even probably do a sample problem here and work that together. We've got this particular company accumulates the following data concerning a mixed cost using miles as the activity level. So in the 4 months, here's the number of miles driven and what the cost was for each of those. So it says compute the variable and fixed elements using the high-low method. Okay, so remember, the first step we needed to do is to calculate the variable cost per unit, take the change in activity divided by the change in total cost. Oh, I apologize, I think I just restated those incorrectly. It's total cost divided by total units of activity. So let's go ahead and find our high and low levels of activity here. Okay, so the high level appears to be March here, where they drove 8,500 miles. And the low level of activity appears to be February here, where they drove 7,500 miles. Okay, so if we take the difference between those two, the cost, we had 15,000 minus the 13,600. So that's a difference of $1,400. And then the change in mileage was 8,500 miles at the high level minus 7,500 miles at the low level, 1,000 miles. So take the $1,400 cost divided by the 1,000 miles, And that gives us a variable cost per unit of $1.40 cost per mile, I guess. Variable cost per mile. Okay, so now that we know our variable cost per mile, let's go ahead and remember that the fixed cost, which is what we now need to solve for, is going to be equal to our total cost minus the total variable cost. Sorry. Okay, so let's pick a level of activity, and I'm going to go ahead and just pick the high level. So the total cost is $15,000, and then we subtract the variable cost per mile of $1.40 times the level of activity here, which was 8,500 miles, and that gives us, looks like, 15,000 minus 11,900, which should be equal to $5,100. No, 4,100. Oh shoot, it's 3,100, I think. Okay. So the fixed cost is $3,100. And you could double check that by also looking at the low level of activity. So if the low level of activity has a cost of $13,600, again, take the $1.04 times 7,500, the level of activity at the low level, and what do we get? We get 10,500, which equals 3,100. Okay, so great. The answer then, again, the fixed cost component is 3,100. The variable cost component is $1.40. We could rewrite that formula. Remember, y equals the 3,100, which is the fixed cost,